All right, so what we have here is another method by which you can start doing some integration. Essentially, what I want to start off with is, you see that crazy long formula right there? Yeah, that's rough. And I don't remember that, and I'm never going to remember it. But what I do remember, and probably you all know already, is the product rule for derivatives, right? So if I have something like d, and I'm just going to write u's and v's, not u of x, v of x, but same thing. If I have the derivative of u times v, that equals the first, right, or the second times the derivative of the first. So derivative of the first times the second plus the first times the derivative of the second. We agree? Do you want me to write the dx's underneath them? I can go through and write an over dx on all of them if you want, but we don't need it there. All right, so I'm going to take that and I'm going to do an integral everywhere. So what I'm going to do is I'm going to integrate everything. Integral of that whole thing, which will actually just be the integral of both of those, right? We agree? So what's the integral of d uv, that first integral? Let me give you a little hint here. Let me give you a little hint here. What's the integral of dx? X. What's the integral of dt? What's the integral of d smiley face? Smiley face, right? What's the integral of duv? uv. We get that? Okay, so this is uv. And then the other part's just that same integral, okay? Now, what I want to do is rewrite this. I'm going to put the u, the integral u dv on the left, and over here I'm going to put u v minus integral v du, like that. And that right there is the formula we're going to use. U du, so we're trying to essentially do the integral of a function times a function that's a derivative of something, and then that's going to equal u times the integral of that dv1, whatever that function happens to be, minus the integral of v du. So in other words, if we have like two functions multiplied together and it's easy to do the integral of one of them and easy to do the derivative of the other, we can do this and start reducing it down to something simpler. So if we take a look at this long, complicated version they have here, so this is the one I like to remember. Okay, and you can do that with, you could do the same sort of thing. Like if we had d dx of f of x g of x equals, it would be g of x f prime of x plus f of x g prime of x. You can go through, you can do the same thing we just did and end up with integral, what did I make u here? Was f of x? Integral f of x g prime of x dx, go through the same steps, is going to equal g of x f of x, or f of x g of x. Doesn't really matter, but I'll just to make it less complicated. F of x g of x minus integral g of x f prime of x, if you prefer it that way, as I run out of room. Sorry. F prime of x dx. So those two are equivalent, if that helps you right there, okay? But essentially, that's what we have there. And you'll see it written sometimes like that. You can see it if we rearrange the terms of this one, like if we rearrange those terms, we end up with integral u of x v prime of x dx equals u of x v of x minus integral v of x u prime of x dx. So that's one way you can look at it. So those are three different ways, you know, that it's all saying the same thing. It's just different notations for it, right? Like the one up there, I didn't write the of x's in them, essentially. I just wrote it in the little shorthand notation. Okay? Whichever version of those, whichever way you prefer it written, that's the way you probably want to go with. All right. How do we go about choosing which of our functions that we're trying to integrate here? Which of those two do I do here? And I don't know. I don't really ever remember this, but maybe I should. Have this nice little acronym. L-I-A-T-E. I don't know. Liate. I don't know. All right. L, this is going to be your logarithms. You want to pick those first. Inverses, or inverse trig, sorry, inverse trig. Your algebraic ones. Your regular trig. And your exponentials. Okay, that's what it's going to go. It's not always going to work in that order. It's not always going to be the great thing to do. Sometimes you might isolate. You might have to change the order. It doesn't work or something. And, you know, sometimes you have to substitute first to get it into something that's going to work. And sometimes in general, you want something that's tends to be as you know, as much of the integrand as you can get, and is also easily integratable. You can integrate it easily. Okay, so best way I find to do these is practice. And there'll be times where you make the wrong choice, like with substitution, where you pick the wrong substitution, you go through and it's not working out, and you got to go back to the beginning and pick something else. All right, so that's going to happen, most likely. So let's look at this one. X times the cosine of x. So if we look at our previous thing, we wanted to pick algebra before trig, right? So we'll try that. What we're going to do is set u equal to x. This will be what we take the derivative of. And then our antiderivative will be our dv equals cosine x dx. Okay? The cosine x dx. So the derivative of uv is just du dx. The antiderivative or integral of cosine is sine. So this will just be v equals sine x, right? We took the integral of both sides like that. So if we write this out, we get, using our, I like this version, so I'm going to copy this over. All right, keep that copied. We're going to write this out. So we're going to get u times v, so that's that's x times sine x minus integral sine x times du, which is just dx. And what's the integral of sine? Derivative of cosine is, so is it negative cosine or are you putting that minus sign in there for me already? Because we have that negative, so, okay. I didn't know if you were telling me like negative cosine or if you were telling me just whatever, I don't know. All right, so this is x sine x, and then it's minus a negative cosine, which becomes the plus cosine x plus c. How about that? How else would you have done that one, right? And if you want to try, if we want to test this or check, we can do d dx of x sine x plus cosine x plus c. The derivative of x sine x is derivative of the first times the second, so that's just sine x, plus the first times the derivative of the second, which is x times derivative of sine is cosine, so plus x cosine x. And then we have the derivative of cosine, which is negative sine x, and the derivative of c is just 0. We have a plus sign and a minus sign, and we're left with just x cosine x, which is what we were trying to integrate, correct? So that worked pretty well, didn't it? Pretty cool? It's like we're using the product rule in reverse order-ish. Okay, so that totally worked for us. All right, let's take a look at this one. Y'all tell me, what should u be? X, okay. U equals x. What does dv equal? Okay, sine x dx, there we go. Sine x dx. So then du, what's du gonna equal? And what is v gonna equal? There we go, negative cosine x. Now, I need, I'll put this up here again, that. So we need u times v. What's that? And there we go, negative x cosine x plus integral cosine x dx, negative x cosine x, and then what's the integral of cosine x? Huh? Sine, right. Derivative of sine is cosine, so this is just plus sine x, and then what? Plus c. Don't forget those plus c's. Okay? Good? All right. Now, that's it for that one. Does that work out nicely? You can even try, I mean, it's always usually a good idea when you've done an integral to take the derivative of it and see if it gives you back what you were trying to integrate, right? Just to make sure. But there you go. Cool? All right. You try. Here, I'll give you a little hint. there are two things there. Remember the liate. I never remember those kinds of things. I don't know why. Except for with the planets. I remember that one. My very educated mother just gave us 9. We have to stop there now, apparently. We don't get to say pizzas anymore. What's that?
Soon you will, because they're very bipolar, whether
yeah.
Pluto is a planet or not.
You hear what happened to Pluto? Man, that's messed up. Probably pause this. All right, time for a little hint here. I did u equals ln of x and dv equals 1 times dx. Who did that? Only 2 of you? Maybe? No? Yeah. Huh?
On the little charts.
Yeah. Logs are your top priority for making them u. So what's du then? 1 over x dx. And what's v? There we go. And so again, paste this up here. There you go. We're going to end up with, nothing. So we end up with x ln x minus integral x times 1 over x dx. So x ln x minus integral dx. X ln x minus x plus c. Cool? And you could check that one. You could do the derivative and you'll get that back, because when you do the product rule, you'll end up with x times 1 over x, and then the derivative of x is also 1, so you have like 1 minus 1. It'll cancel. All right. What about this one? We have an exponential and a trig, right? Huh? Okay. So what are you going to make u? Okay. And then dv. Okay, I'll pause a minute, let y'all try. So as y'all have probably found here, this one gets a little repetitive, right? So we come here, we say this is du, this is negative sine x dx, v equals e to the x, and so our integral becomes e to the x cosine x, right, uv, minus v e to the x times negative sine x dx, like that, right? And then that becomes e to the x cosine x plus integral e to the x sine x. And so we look at that and say, oh, wait, that right there is another u substitution thing, right? So we'll take a look at this one. Here we say u equals sine x, and dv is e to the x again, dx. And so du becomes cosine x dx, and v is e to the x again. And so then this equals, keep that first part, e to the x cosine x plus, and then we'll have e to the x sine x minus integral e to the x cosine x dx. And we're right back to having to take the integral of what we started with. So we're out of luck, right? Nope. Take a little trick. We're going to add that integral to both sides. And so what I'm going to do, so I'm going to come down here, I'm going to say, all right, I take this integral right here and I add it to both sides. And I get 2 times the integral e to the x cosine x dx equals e to the x cosine x plus e to the x sine x. See that? Then I'm going to divide both sides by 2. And I get integral e to the x cosine x dx equals e to the x cosine x plus e to the x sine x over 2 plus c. Family of solutions, right? Wasn't that one fun? Oh, come on. It was plenty of fun. Plenty of fun. That's a neat one. There's our answer. All right. No, you getting it? I like that one. Okay, let's take a look at this one. X squared e to the x. Now I'm going to go ahead and do these because we're getting down to our last 10 minutes here, and I want to show you the next 2 here. Just 2, I believe. Yeah. Let's finish this off here. So, or actually, I might do this one and then let you maybe work on the last one before showing you next time. So, x squared e to the x. So let's start with this. We've got exponential, which is our last choice. So we're going to pick the algebraic one first, right? So this is u equals x squared, dv equals e to the x dx, just like that. So du is 2x dx, and v is just e to the x. So this becomes x squared e to the x minus integral e to the x and then 2x dx. And then again, I need to do this again, right? I guess I can rewrite this. X squared e to the x minus 2 integral x e to the x dx. Just bringing that 2 out in front. So I have x e to the x. So I'm going to pick it again. I'm going to say u equals x, dv equals e to the x dx again, du equals dx, v equals e to the x. Okay? So we get x squared e to the x minus 2x e to the x, right? And now it would be minus that integral. Well, I'll just put it in parentheses. How about that? Minus integral e to the x dx, like that, right? And then I can distribute that minus 2. I get x squared e to the x minus 2x e to the x plus 2 times that integral. What is that integral? E to the x. And then plus c. And there's our answer. There you go.
So we can do integration by parts as much as needed.
Yep.
You don't have to do it once.
Correct. Why not? It's just another integral. If integration by parts keeps progressing you. So if this was like, excuse me, if this was like x to the 100th times e to the x dx, just keep doing it till it eventually goes away, right? I'm not saying that would be a fun way to do it. You'd probably start to look for some sort of pattern and then try to repeat the pattern, right? X squared e to the x minus 2x e to the x plus 2e to the x. Yeah. Okay. I'm sure you'd find some sort of pattern, but we have an alternative method here. We'll take a look at this. Whenever we're doing that kind of thing, we have an alternative, kind of a shortcutty method to this called the tabular method. And so essentially what we've got here is we have what that integral equaled, right? But we can shortcut our way through it. Instead of doing all these substitutions, what we can do is pick our derivative side, which is our u equals x squared. So this is our derivative side. And this is our anti-derivative side. That's our dv equals e to the x. And then what we can do is start taking derivatives. So this is x squared, 2x, 2, 0. This is e to the x, e to the x, e to the x, e to the x. And what we want to do is pair them up. And we're going to pair them this way, diagonally across like that. Okay, that wasn't a very good arrow. Just like that. And then we're just going to write it down. We're going to say, what was it? Integral x squared e to the x dx. And what we're going to do is we're going to pair them, pair, diagonal like that. And then we're going to start, we're going to start with a plus and alternate our signs. Okay? So that's what we're going to do, that and that. So we're going to go x squared e to the x positive, and then we're going to go minus 2x e to the x, and then we're going to go plus 2 e to the x, and then we're just going to add on our c at the end. And look at our answers.
That always works.
Yeah. If you have to do this multiple times, it's just, I mean, it's the same thing, right? Isn't that what we did up here? X squared to 2 to the x, and then we went x dx. I mean, we just kept taking the derivative down, right? When we have a situation like that. So it's just, it's the same exact thing. We're just doing it in a different order. And then the signs alternate because we'll do minus the integral. And then we end up with a minus, so then it becomes a positive, right? And then it's minus the positive. And so the signs will alternate. And you will just go through pairing up, like we paired up x and v. So we paired up, wherever that was, we had the 2 on it. But anyway, you end up pairing them up, 2x e to the x, 2x e to the x, right? So we had that 2 with it, but that's all we ended up doing was pairing them, right? So yeah. So we have about 4 minutes left. Take a look at this one and tabulatify. Use tabletification on it. Okay, give it a try. Total Here, there it is in the video, workout. Pause it and take a look.